Hello, and thanks for tuning in to this 2020 NACCHO Preparedness Summit on-demand presentation. This on-demand presentation is part of Track 1, Building and Sustaining Resilient Communities. The overall session name is Long-Term Power Outages in Public Health, Perspectives from Practitioners. I hope you got the chance to watch Part A of this session, Long-Term Power Outages in Public Health, Perspective from Practitioners. This presentation is Part B, Modeling Resilient Hospitals, Critical Operations Persistence During Extended Power Outages. Long-term loss of electrical power is a major disabling obstacle to critical hospital operations. This session will introduce an ongoing effort by experts in hospital operations and model-based systems engineering to develop ways that hospitals can best deal with this threat and continue to serve our communities. First off, let me give you the main objective of this session. The objective of Part B of this learning session is to introduce an ongoing project by a volunteer cross-domain team to apply current and modern analysis, engineering, and evaluation methods to develop a model-based decision support capabilities that hospitals can use to enhance resilience planning, education, execution, recovery, evaluation, and reporting. Now, there's one important theme you'll hear me mention more than once. That is, our engineering project team, along with key stakeholders from the healthcare community, is trying to design, develop, prove out, and offer to hospitals a new kind of what we hope will be a useful decision support capability. That is, an analysis, decision-making, assessment, and reporting capability that will take full advantage of current and modern technologies, but still be easy to learn and familiar to use. A capability that will be easy to incorporate into existing decision support tools without users having to learn any new or different skills. The project team is made up of systems engineering practitioners from the International Council on Systems Engineering, or NCOSE, IEEE, and FBI-sponsored InfraGard, as well as experts from prominent healthcare organizations such as the Society for Disaster Medicine and Public Health, SDMPH, and of course, NACCHO. Notice the QR codes here. Anyone with a QR code reader should be able to scan these codes and get directly to the URLs listed here. Here's some background information on what we're calling the Resilient Hospital Reference Model Model-Based Systems Engineering Project. The project was motivated by the initial work captured in the booklet Resilient Hospitals Handbook, co-authored by Chuck Mantle of InfraGard and Drs. Terbush and Matzer. More about this handbook later. Following its publication in a series of subsequent discussions, it was decided that follow-up systems engineering could prove very helpful based on the potential model-based contributions from several NCOSE working groups in collaboration with key stakeholders from IEEE, InfraGard, SDMPH, NACCHO, and other healthcare organizations. Now, I'll be introducing all of these terms you see here as I go along. Here's the purpose, goal, and vision for the project. The project purpose is to develop a generic resilient hospital reference model to enhance current planning for preparedness, protection, prevention, response, mitigation, and recovery, initially as they pertain to hospital prolonged power outages. Now, a project goal is to provide all hospitals with a resilient hospital decision support capability, leveraging model-based systems engineering techniques and tools that hospitals can use to enhance planning before, during, and after prolonged power outages. A project vision is this resilient hospital decision support capability can be replicated and scaled to offer the same kinds of model-based tools and resources at the public health care, local, tribal, state, regional, and national levels. As I mentioned, in the next few slides, I'll introduce some terms the project team is using, starting with who we are, systems engineers, practicing systems engineering. Now, systems engineering is a transdisciplinary approach to overall engineering. a means to enable the realization of successful full system solutions. These systems will satisfy the needs of customers, sponsors, users, and other stakeholders. And a systems engineer is a person or role who supports this transdisciplinary approach. They elicit and translate stakeholder needs into requirements that can be realized by the system development teams. They support a set of life cycle processes beginning early in conceptual design and continuing throughout the life cycle of the system, including its manufacture, deployment, use, and disposal. And they help ensure that elements of the system fit together to accomplish the objectives of the whole system solution. The title of this slide is Systems Engineering Transforming Needs to Solutions. Systems engineers are at the heart of creating successful new system solutions. They are responsible for the overall system concept, architecture, and design. They analyze and manage complexity and risk. They decide how to measure the deployed system to where it actually works as intended. Systems engineering is a discipline that makes their success possible. Their tools, techniques, methods, knowledge, and standards, as well as principles and concepts. The launch of successful systems can usually be traced to innovative and effective systems engineering. The next project term I'll bring up is modeling. Now this slide runs through the idea of modeling as well as what modeling brings to the table. That is, rapid initial recording of reference information in common descriptions and diagrams stored all together in a shareable relational repository. Modeling enables the production of common collaborative environments, promoting shared human understanding. The integration of all system components throughout the entire development lifecycle across healthcare, including emergency management systems, from concept through compliance, development, training, operations, support, evaluation, assessment, and reporting. Analysts, planners, hospital staff, and other decision makers can simultaneously represent reference information from many different perspectives and viewpoints, and there is immediate knowledge by all stakeholders of changes made to reference information by any other stakeholder. Here's an example of how modeling is being used in the healthcare community, offered by one of our volunteer project team systems engineers currently practicing systems engineering in the healthcare domain. It shows a single model of a problem scenario that was put together from several sources. For example, from extensive stakeholder interviews, discussions in 2 hospital settings, process notes, hospital data, literature reviews, etc. This particular model example captures patient arrival. The exact scenario being modeled here is patient flow. A main takeaway message: for effective emergency department patient flow solutions, one needs to consider downstream processes as well as intra and interdepartmental interfaces to address emergency departments' changing patient flow needs. Systems engineering-based methods such as model-based systems engineering will allow for not only capturing the problem, but also performing analysis and identifying solution alternatives. The next project term that I'll introduce is model-based systems engineering, or what we call MBSE. MBSE, or model-based systems engineering, encourages systems engineering best practices through the use of models, that is, data, diagrams, and descriptions captured and related together in a common digital repository. Systems engineering models are often represented in digital form and may describe requirement analysis, design, verification, and validation of system frameworks or system components. Modeling tools enable users to identify system interdependencies and interfaces in real time, such that changes to any part of the system are immediately flagged in every other related part of the system. Additionally, modelers can more efficiently prototype and explore both system structure and behavior at lower cost when compared with traditional paper-based systems engineering. Here are the main concepts behind model-based systems engineering. Systems engineering requires structural, behavioral, physics, and simulation-based models representing the technical designs which evolve throughout the system development lifecycle. Current practice tends to rely on standalone discipline-specific models like the kind you see on the left, whose characteristics are shared primarily through static documents or files. Model-based systems engineering, on the other hand, that you see on the right, moves toward a shared system model, with remaining discipline-specific models providing their characteristic information in a measurable and shareable manner if or when they become relevant to the whole system. All disciplines view a consistent system model. The next and the last project term I'll introduce is the idea of reference models. Reference models consist of hardware and software, data and operational models developed using MBSE tools and techniques, and all related documentation, enabling focused assessment and planning in stable and comparable test environments, representation of both simulated and real-world events, rapid event knowledge reconstruction, reuse, and relay, that is collaboration, accelerated test and evaluation cycles, including generating and evaluating scenarios for healthcare preparedness and response strategies. Here's a general reference model. It's meant to represent the efficient and effective integration of the primary types of current and modern software-based system solution models, that is, information models, business models, performance or behavior models, and application models. Here's an example of a healthcare reference model taken from a 2010 conference paper presented by a colleague of one of our IEEE Computer Society project team members. The picture itself is kind of blurry, but I hope it clearly enough shows how the project team plans to use model-based systems engineering best practices to model in an integrated fashion hospital information, behavior and structure aspects you see across the top, clinical information, patients, process, and hospital domains, and technical data, application, and infrastructure domains. Here is a picture of the MBSE vision offered by our project team member practicing in the healthcare domain. Development of this picture is based on grants submitted on hospital emergency department work. A key point here is that a good reference model forms the basis for developing increasing capabilities. The last project term I'll introduce is resilient hospital reference models. This sort of ties together the other terms, systems engineering, modeling, model-based systems engineering, and reference model. These resilient hospital reference models enable hospitals in general to model in a collaborative fashion, that is, describe and diagram in a common repository, and share reference information about hospital critical operations. It allows for the establishment of a common reference framework. And it effectively and efficiently helps coordinate the provision of resources and services. These models will enable planning and decision making in compliance with all local, tribal, state, regional, and national references, for example, guidance, requirements, standards, etc. And they're meant to be flexible and scalable to enable hospitals to successfully integrate their operational references into broader healthcare coalition, catastrophic event planning, execution, and evaluation frameworks, as well as national emergency healthcare response systems. This hospital reference model example, again offered by our project team member currently practicing healthcare MBSE, illustrates a high-level project objective to build a sophisticated hospital reference model that captures interactions between departments and other additional factors. A project goal is that a hospital analyst could use such a reference model, for example, to enhance the optimization of patient flow under specific catastrophic conditions, such as a prolonged power outage. Once such an optimized configuration is reached, any changes to the flow could be analyzed and implemented in an effective, efficient, and timely manner. Here's a general roadmap for the Resilient Hospital Reference Model, Model-Based Systems Engineering project. The x-axis along the bottom is roughly a project timeline. The y-axis, up and down on the left, shows increasing project outcomes maturity. The banner across the top includes example high-level capabilities for the system solution that we hope can be developed and refined during the course of the project. And the blue bullets in the lower right are just representative high-level project team processes that the project team will be following. Like any project roadmap, this one will be constantly updated as needed based on inevitable changes that we know will influence our current or planned project work. Here's some of the activities the project team has gotten done to this point. Referring back to the project roadmap on the previous slide, the team has facilitated a series of 3 initial project planning interactive workshops. Those workshops were attended by engineering, modeling, and management decision makers, as well as experts from multiple healthcare organizations. The primary output from these workshops was a series of what we call project focus mechanisms, captured in a very detailed Microsoft Excel workbook, which the team hopes will help focus and guide Resilient Hospital Reference Model design, development, and deployment throughout the project lifecycle. And right now we're continuing to gather historical, current, and planned reference and governance information specifically related to hospital critical operations before, during, and after prolonged power outages. Now, we already have an extensive searchable PDF library of this reference information, including current versions of governance documents and current news articles, all related specifically to hospital power outages. And this hospital power outage PDF library of reference information can be made available to anyone upon request. And we are continuing to perform outreach to socialize our project plans and activities and to solicit project members and key stakeholders. Here are some of the next things the project team will be working on. Again, referring to the project roadmap slides shown earlier, the project team is now leveraging its information gathering, initial project planning, and outreach work to, in a collaborative fashion, work with project key stakeholders to develop a model-based concept definition of current hospital critical operations that could be affected during a prolonged power outage. And those are the yellow blocks on the roadmap named Hospital Critical Functions Modeling, Hospital Critical Interface Modeling, and Hospital Reference Model Development. Here's some project-related events that team members have attended and plan to attend. As I mentioned before, the team held 3 Resilient Hospital Reference Model, Model-Based Systems Engineering project, initial project planning workshops at the Johns Hopkins University Applied Physics Laboratory in April through October of 2018. Those workshops were attended by NCOSE members, IEEE systems engineers, InfraGard representatives, and as well as representatives from SDMPH and NACCHO and other healthcare organizations. The team presented a project paper at the SDMPH meeting in Puerto Rico in February of last year, and one of our project team members presented a project status at the SDMPH national meeting in August of last year. And team members gave a project status briefing at the Colorado South Central Healthcare Coalition meeting in January of this year. And some of the members attended NACCHO 360 virtual conference in July. And of course, we're giving this presentation here at the NACCHO Preparedness Summit. And we plan to participate in EarthX 2020 exercise during the month of September of this year. And we have a proposal in to give the project status update again at an International Council on Systems Engineering Healthcare Working Group Systems Engineering Conference, which is going to be held in a virtual manner in November of this year. Here are some icons for just some of the many healthcare domain references the project team has been collecting and using. A primary goal of the project is to help healthcare experts transition from complying with and employing such a myriad of paper-based or file-based references, separate paper and separate references, into a more current and modern computer-based analysis, decision-making, and evaluation and reporting digital environment based on a relational and shareable, collaborative data information and model-based reference framework. I wanted to highlight one of the primary references the project team has been using. It's a very small but very informative pamphlet containing information about resilient hospitals. The co-authors include two members of the project team, Mr. Chuck Manto of InfraGard and Jim Turbush, MD, MPH. The URLs at the bottom of this slide show where you can purchase a paper pamphlet and also two sites where you can download a free PDF version. Here's some contact information for some of the project team members. This volunteer project is always looking for new team members or key stakeholders who can give the team advice and guidance on a continuing as available basis. Please contact the project team lead, Howard Likens, if you would like to know more about the project, or if you would like to join the project as a team member or key stakeholder. The other project team members listed here can also answer questions about project background, history, and ongoing or planned work. Thanks again for allowing us to give this project status presentation, and enjoy the rest of the 2020 NACCHO Preparedness Summit.